Hey fam, this is review notes on reciprocal rational functions. Let's review 3 problems together. Let's look at what happens when we try and graph the function f of x equals 1 over x plus 2. This is a reciprocal function because the x is in the denominator and there's no x on top, or else it would be rational. So let's go ahead and graph this. The weird thing about this is that when you plug in something for x that makes the denominator equal to 0, you'll be dividing by 0, which is not possible in mathematics. So when we plug in a negative 2 for x, when we plug in an input of negative 2, that's going to make the denominator equal to 0. You can't have anything divided by 0, so this creates what we call an asymptote. So there's an asymptote where x equals negative 2. So where is x equal to negative 2? Well, we have to move on the x-axis, negative 2 to the left. So that's 1, 2. Right here is where x is equal to 2. However, x is also equal to negative 2 down here, down here, down here, up here, up here, up here, because all of these point, the x value is negative 2. So x equals negative 2 is actually this line. Right here. So at every point on this line, this function cannot exist. So let's look at what happens to this function when x is close to negative 2, but not exactly equal to negative 2. Let's try and plug in negative 1, 0, and let's try some points on the other side also, negative 3 and negative 4. When we plug in a negative 1, you're going to get negative 1 plus 2, which is equal to 1 over 1, or just 1. When you plug in a 0, you'll get 0 plus 2, which is 2, so you'll get 1 over 2. When you plug in a negative 3 for x, you'll get negative 3 plus 2, which is negative 1, or just 1 divided by negative 1 is negative 1. And lastly, when you plug in negative 4, you'll get negative 2 on bottom. So if we plot these points, negative 1, comma 1, zero, 1/2, negative 3, negative 1, and negative 4, negative 1/2, we can see that it's a strange pattern. Now, if we try a couple points a little bit closer to the asymptote, we'll see exactly what's happening. So let's try the points just a half a step away from the asymptote. Let's try negative 1/2 and negative 2.5. So let's try negative 1.5 and negative 2.5. Well, when we plug in negative 1.5, we're going to get a 0.5 here. So that's the same as 1 over 0.5, which is actually equal to 2, because 2 halves go into a whole. And similarly, when we subtract negative 2.5 plus 2, we'll get 1 over negative 0.5, which is negative 2. So let's plot these 2 points and we'll see exactly what happens as x approaches the asymptote. So negative 1/2, positive 2, and negative 2.5, negative 2. As you can see, it gets closer, it decreases on the left side, and it actually is also decreasing on the right side. What you're going to get is a function that follows this curve. going to be two lines that it actually never touches, but it gets very close to. So one of those asymptotes is this one right here, and we'll make it a dash line so you can see that this is an asymptote. And if you'll notice, the other line that it gets really close to but never touches is the x-axis, which at every point y is equal to 0 because it's not up or down, and that represents y. So this line is y equals 0. So this has two asymptotes. The horizontal asymptote is y equals 0, the horizontal asymptote. And the vertical asymptote is x equals -2. Now you should be able to tell that just by looking at the equation, because if we look back at our equation, let me write it nice and big for us. Our equation right here has a positive 2 in the denominator, so we think what makes that equal to 0, that's when x equals -2. That's our vertical asymptote. And then since there's no x on top, and we'll talk a little bit about this in subsequent videos, but since there's no x on top, our horizontal asymptote, just like in this problem, is going to be where y is equal to 0. Let's try one more together so that we can see what happens when there's a negative value in front. Let's try f of x equals -1 over x minus 3. Pause the video and tell me what's the vertical asymptote going to be. Alright, let's see. So what you wanted to think to yourself was, what would I plug in for x in order to make the value of the denominator equal to 0? And that would be x equals +3 in this case, because +3 minus 3 is equal to 0. So there should be a vertical asymptote at +3. Alright, where would the horizontal asymptote be? Horizontal asymptote, since there's no x on top, would be at y equals 0. Now you know the general shape of a reciprocal function, but let's see what happens now that there's a negative in front. Let's go ahead and plug in some values near the vertical asymptote, x equals 3. So let's try x equals 2. Let's try x equals 4. Let's try x equals 1. And let's try x equals 5. So that we can make sure that we're drawing the function on the right quadrants. Alright, so when x equals 2, you plug in a 2. That's 2 minus 3, which is -1. But there's a negative, so negative 1 makes it positive. So this will come out as +1. Plug in a 4, 4 minus 3 is +1, but this makes it negative, so this will be -1. Plug in a 1, 1 minus 3 is -2, but this makes it positive, so that's +1/2. And similarly, 5 minus 3 is 2, but negative because the negative's in front, -1/2. So there's a point at 2, 1, 2, 1, 4, -1, 1, 1/2, 5, -1/2. So as you can see, it's taking a similar shape, but it's slightly different. Because now, the function is increasing in slope as we move to the right. So this is a graph of f of x equals -1 over x minus 3. Now, let's say you're given a slightly different problem. Let's say you're given a couple of characteristics or parameters of the graph. Let's say the vertical asymptote and the horizontal asymptote are given to you. Let's say that the vertical asymptote is x equals -2, and the horizontal asymptote is y equals 0. And it asks you, what is the equation? Well, there's a few possible answers for this, but you do know two things. You know that the horizontal asymptote is y equals 0, which means that you have a constant on top. So it could be a 1, or it could be a 2, or it could be a -7.5. You don't know, but you know the numerator is a constant. The other thing you know is that the vertical asymptote is at -2, which means that -2 would make the denominator equals to 0. So that must mean that it is a +2 down here, because when you plug in a -2, it'll be 0. So this must be x plus 2. The negative would make the positive cancel out. This would be 0. So it must be x plus 2 in the denominator no matter what. So any of these equations would fit these restrictions. And here's what the graph might look like. Pause it and see if you can draw it. Okay, so there's a vertical asymptote at x equals -2. That's this line right here. There's a horizontal asymptote at y equals 0. And the graph could look like this. Or it could also look like this. You would either get this red function or this brown function. Hopefully this helps you with your quiz review. There are two questions in particular on level 3 and level 4 that hopefully you should be able to do now on your own.